Last time on Fact Voyage, we talked about the weapons of geoeconomic confrontation, the tariffs, the sanctions, the export bans that governments are now using as tools of power rather than tools of commerce. Today, we're looking at the ammunition. For most of the 20th century, one word defined global power: oil. Nations went to war over it. Alliances were built around it. Economies collapsed without it. The country that controlled oil controlled the century. But here's the thing. We knew where the oil was. We knew who had it. We had decades to build the systems, the treaties, the institutions around it. What's coming next is different. The minerals that will power the 21st century, the ones inside your phone, your electric car, your fighter jet, and the artificial intelligence data center processing your internet search right now, are concentrated in ways that make the old oil map look simple. And the race to control them is not on the horizon, it is already underway. So what exactly makes a critical mineral scarce? It is not scarcity in the ground. Rare earth elements are actually relatively abundant in the Earth's crust. The name is a bit of a misnomer. A mineral becomes critical when three things converge at the same time. It is essential to modern technology or national defense. There are very few viable places to obtain or process it, and substituting it with something else is difficult or impossible in the short run. When all three are true, you have a critical mineral, and you have a potential choke point in the global economy. Let's be specific. Lithium goes into every electric vehicle battery on the planet. Cobalt makes those batteries thermally stable and safe. Neodymium and dysprosium go into permanent magnets that power electric vehicle motors, wind turbines, and precision-guided missiles. Gallium is essential for semiconductor manufacturing. Graphite forms the anode in every lithium-ion battery ever made. None of these have easy or ready replacements, and the vast majority of them flow through one country before they ever reach you. That country is China. China's dominance over critical minerals did not happen by accident, and it did not happen overnight. It was the result of a deliberate, multi-decade industrial strategy, and the West watched it unfold and, for the most part, looked the other way. It started in the 1970s. While Western companies were optimizing for profit margins and outsourcing to the cheapest available producer, China was quietly and patiently investing in becoming the world's indispensable mineral processor. Not the biggest miner, the biggest refiner. That distinction matters enormously, and we will come back to it. The work was dangerous. The environmental cost was enormous. Mining and refining rare earth elements generates acidic wastewater, heavy metals, and radioactive byproducts, including thorium and uranium. It involves hundreds of extraction stages, each requiring highly toxic acids. Western nations, with their environmental regulations, their worker protections, their democratic accountability, stepped back from those costs. China did not. Decade after decade, Beijing invested in processing capacity, subsidized its domestic industry, absorbed the environmental damage at the local level, and gradually cornered the market, not by finding more minerals in the ground, but by building the infrastructure to turn raw ore into usable materials. Today, the numbers are stark. China supplies 91% of refined rare earths globally. It produces 92% of the world's rare earth permanent magnets. By 2035, it is projected to supply over 80% of battery-grade graphite, over 60% of refined lithium and cobalt, and approximately 70% of battery-grade manganese. Think about those numbers for a moment. We are not talking about a market advantage that could be competed away in a few years. We are talking about structural dependency. An entire generation of global supply chains was built assuming China would always be a reliable, willing supplier. That assumption is now being tested. For years, China's mineral dominance was what strategists call a latent threat. Everyone who studied it knew it existed. It sat in think tank reports and congressional testimony and academic papers. But it remained abstract, a theoretical vulnerability rather than a live crisis. Then, in 2025, Beijing pulled the trigger. In retaliation for U.S. restrictions on advanced semiconductor exports and the sweeping tariffs introduced by the Trump administration, China rolled out a wave of export controls targeting germanium, gallium, and then, most consequentially, rare earth elements, specifically the heavy rare earths, the elements that are hardest to substitute, hardest to source elsewhere, and almost exclusively processed in China. Chinese suppliers were now required to obtain licenses from China's Ministry of Commerce before any export could proceed. No license, no shipment. And the licensing process was deliberately opaque, slow, and unpredictable. The effect on manufacturers was immediate. Companies that depended on Chinese rare earth magnets, from electric vehicle producers to aerospace contractors to defense suppliers, faced sudden, serious supply uncertainty. The military implications were particularly alarming. The F-35 fighter jet requires rare earths for its motors, actuators, radar systems, and sensors. Nuclear submarines depend on them for quiet propulsion systems. Precision-guided munitions use rare earth permanent magnets to drive their control surfaces. These are not luxury components. They are not easily swapped out. The United States, at that point, maintained strategic stockpiles of certain rare earth materials, roughly 1,100 tons of lanthanum, 300 tons of oxide, and 450 tons of magnet reserves. Enough to buy some time, but not enough to sustain long-term production if Chinese supply was genuinely severed. China had not just played its card, it had shown the world exactly what kind of hand it had been holding all along. Washington's response has been fast, ambitious, and very expensive. In February 2026, the United States hosted a critical minerals ministerial of the State Department. Representatives from 54 countries attended. The goal was simple to state and enormously difficult to achieve: build a rival supply chain outside China at scale, quickly. Secretary of State Marco Rubio used the summit to warn of the risks of having the world's critical mineral processing concentrated in a single country and to call for a new preferential trading bloc for minerals among allied nations. On the same week, President Trump unveiled Project Vault, a $12 billion reserve fund backed by $10 billion from the U.S. Export-Import Bank and $2 billion in private capital, designed to stabilize mineral prices and protect American manufacturers from future Chinese supply disruptions. The stockpile would include rare earths, lithium, and copper. The U.S. signed bilateral critical minerals agreements with 11 countries at the summit. Negotiations were concluded with 17 additional nations. Clean trade and investment partnerships were established to create new supply routes. Washington is also pushing for coordinated price floors among allied mineral producers, a mechanism to prevent China from simply undercutting alternative suppliers with cheap, state-subsidized exports the moment rivals try to enter the market. This has happened before. Every time a Western rare earth project has come close to commercial viability, Chinese producers have flooded the market and driven prices below the break-even point. The price floor mechanism is designed to prevent that from happening again. Meanwhile, on the private side, U.S. Rare Earth acquired Brazil's Serra Verde, one of South America's most significant rare earth miners, in a cash and stock deal worth $2.8 billion. Serra Verde had already secured a $565 million financing deal with Washington earlier in the year. The acquisitions are part of a broader effort to assemble a non-Chinese supply chain from the ground up. The problem, and this is the uncomfortable part, is that processing facilities take years to permit and construct. Skilled labor must be trained from scratch. Supply chains that took China 50 years to build cannot be replicated in a single presidential term or even two. The gap between urgency and capability is enormous. The deal bought time. It did not solve the underlying problem. The United States is not the only one scrambling. The European Union has designated 60 strategic projects specifically targeting lithium, graphite, cobalt, nickel, and rare earths. 47 of these are located within EU member states. 13 are in partner countries, including Canada, Kazakhstan, Ukraine, and Zambia. The EU also co-convened its first-ever business and investment dialogue with Saudi Arabia on critical raw materials at the 2026 Future Minerals Forum, a signal that Europe is casting its net well beyond its traditional partners. But perhaps the most significant geopolitical consequence of the minerals race is happening somewhere that rarely gets the attention it deserves: Africa. The Democratic Republic of Congo holds over 70% of the world's cobalt reserves. Zimbabwe has significant lithium and platinum deposits. Namibia, Zambia, and South Africa are all home to substantial critical mineral resources that the world suddenly, urgently needs. For the first time in decades, arguably for the first time since the colonial era ended, resource-rich African nations find themselves with genuine geopolitical leverage. The United States wants their minerals, the European Union wants their minerals, and China, which has been investing in African extraction through its Belt and Road Initiative for years, wants to keep its position. That competition is creating real economic opportunities for African governments. New agreements, new financing, new infrastructure investment are all flowing in. Whether African nations can translate that leverage into lasting development rather than simply becoming the latest resource providers for richer nations' industrial ambitions is one of the defining questions of the next decade. Here is the uncomfortable truth that tends to get lost in all the alarm and all the diplomatic activity. China's dominance over critical minerals was not built on geological luck. The minerals are not rare. They exist on every continent in economically significant quantities. Australia has rare earths, Brazil has rare earths, Canada, Greenland, India, Vietnam all have meaningful deposits. China's monopoly was built on something else entirely: a willingness to accept human and environmental costs that free market democracies chose, quite deliberately, not to absorb. Low labor costs, weak environmental enforcement, local governments absorbing the toxic externalities of refining operations for decades. That is what created the structural dependency, not some irreplaceable natural advantage that only China possesses, which means it can, in principle, be broken. But breaking it requires Western governments to do something that cuts against the grain of how democracies tend to work. Commit to a heavy, long-term industrial strategy that will not pay off within a single electoral cycle. Invest for decades, accept environmental trade-offs, sustain political will across changing governments and changing priorities. That is genuinely difficult, and Beijing knows it. Analysts at the Center for Strategic and International Studies have warned that current de-risking efforts, while real and meaningful, are unlikely to fundamentally alter China's grip on critical mineral supply chains within the near term. Consider the comparison. MP Materials, the only significant rare earth operation currently running in the United States, produces less than half of what Lynas, the world's largest non-Chinese rare earth refiner operating out of Malaysia, produces. And even Lynas represents only a small fraction of China's total refining capacity. The gap is real. The timeline to close it is long, and China retains the ability at any moment to selectively cut off supply and create pain faster than alternatives can be built. There is, however, a reason for qualified optimism. The 2025 export control episode did something important. It shattered the complacency. As one analyst at CSIS put it, China overplayed its hand, and that cannot be undone. The episode proved the vulnerability was real, not theoretical, and it accelerated investment, legislation, and international cooperation at a pace that simply would not have happened without the shock. The question now is whether that momentum can be sustained long enough to matter. Step back and look at the full picture. Whoever controls critical minerals controls the hardware of the 21st century. The clean energy transition runs on them. The artificial intelligence revolution runs on them. The next generation of military capability runs on them. None of it works without a steady, reliable supply of the materials we have spent this episode discussing. And the chessboard is set up in a way that no single diplomatic summit, no single $12 billion reserve fund, and no single bilateral trade agreement can quickly undo. This is a decade-long contest at minimum. The West is playing catch-up. Africa is finally holding real cards. China, for all the noise about decoupling, remains structurally indispensable to the very supply chains the world is urgently trying to build without it. That tension between the strategic necessity to reduce dependence on China and the economic impossibility of doing so quickly is one of the defining contradictions of our era, and it connects directly back to what we covered in our last episode. The minerals race is not separate from geoeconomic confrontation. It is geoeconomic confrontation. The tariffs, the export controls, the investment restrictions, all of it is downstream of this fundamental struggle over who controls the raw materials the modern world cannot function without. If the 20th century was defined by oil, by who had it, who needed it, and what people were willing to do to secure it, then the 21st century will be defined by lithium, cobalt, rare earths, and graphite. The voyage has only just begun. Stay with us, subscribe for the next episode, and we will see you on the next Fact Voyage.